integration. Integration is also called the antiderivative. See, f of x is equal to y. That is, y is the dependent function, whereas dependent variable, whereas x is the independent variable. Based on the input, based on the x, the y will vary. And that is why we call y as a dependent variable, x as an independent variable, x being the input and y will be the output. So y is equal to f of x is a function. And when it is differentiated, it becomes f dash x, which is also represented as a dy by dx. Now, when you reverse it by using the integral technique, you can get back the original function, and that is why it's called antiderivative. For example, let us consider f of x is equal to x power n, and when it is integrated, that is f dash x is equal to x power n. When it is integrated, so we get, that is, we know the formula f dash x when it is integrated, assuming that it is x power n. So this is equal to x power n. Then you are able to get x power n plus 1 divided by n plus 1 plus c. Okay, suppose if f dash x is equal to 6x dx, okay, and then now it can be integrated as follows. We are integrating, 6 is constant, take outside the bracket, and now it becomes 6 into x power 1 plus, this is x squared, so 2 plus 1 divided by 2 plus 1 according to this formula, n plus 1 divided by n plus 1, okay, plus integral constant, so 6 into x cube divided by 3, it means 2x cube. Okay, so this is the way we work out, and that is the original f of x function. Okay, then, and regarding the integration representation, this symbol represents integral, and f of x is called the integrand, and dx is the differential element, where x is the variable of integration, and it's also called integrator. So on solving this by integration, you are able to get antiderivative. Okay, so that is capital F of x, and that leads to the original function plus the arbitrary constant, here the integral constant c. Okay, and this integral can be further classified into definite integral and indefinite integral. Indefinite integral, it has no interval or limits, so we need to essentially include the integral constant, whereas in the case of definite integral, we had to evaluate the integrated value by substituting the final value and subtracting the initial value. Okay, and we will be discussing everything in detail then. Now let us go through the derivatives and the integral formula. See, on differentiation of a constant, it becomes a 0, but in the case of antiderivation, that is antiderivative, that is integration, on that is, this is nothing but 0 dx means 0. So it means that leads to constant in this case. And here, when you got a constant into x, okay, of that gives you k, whereas in this case on integration of k into dx, it becomes, that is, kx. I can explain this further. For example, we have the formula x power n. When it is integrated, it becomes, that is, x power n plus 1 divided by x power n plus 1. So when you have this integral k dx, means, that is, k can be taken outside the integral and simply dx, it means we can call it x power 0, that is, x power 0 is equal to 1, and that is why we are able to get k into x power 0 plus 1 divided by 0 plus 1, and that leads to kx. Are you able to follow? Because 0 plus 1 means 1, so x power 1 kx divided by 1, so kx. Okay. Right. Next, let us consider, suppose we have got y is equal to 5, that is the constant. On a differentiation, we are able to get 0. But here, y is equal to c, on differentiation of any constant as an isolated one, that becomes a 0. But dy by dx is equal to 0, so in this case, dx goes here, so dy 0 into dx. Okay, 0 into dx means, that is, it gives rise to that value 5. Okay, because the final limit is 5 and we can get back the original value, and that is why we call it anti-derivative. Let us consider this problem. Here y is equal to 5x plus 2. So on differentiation, dy by dx, it becomes x, that is, it is eliminated, so 5. So what is the formula we adopt here as far as differentiation is concerned? Here we adopt, this is x power 1, is it not? So x power n means on differentiation n x power n minus 1. So in this case, you have, this is constant, forget about it, and x is here, so x power 1. So when you differentiate, it becomes 5 into 1 and x, then 1 minus 1. It means that is a 5 into 1, 5 into x power 0. X power 0 is equal to 1, and that is why we put simply 5. Okay, are you able to follow? But at the same time, now you have got the constant as an isolated one. When it is differentiated, it is 0. But when it is associated with the variable, it cannot be 0. Okay, so that you have to note down. But in the case of dy by dx is equal to 5, here dy is equal to, this dx can be brought to the other side, so it becomes a 5 dx. Now let us integrate on both sides. So dy on differentiation becomes y, and the 5 dx, 5 can be taken outside the bracket. And what about this? This is x power 0. So dx on integration gives x, okay, plus integral constant, right? Now let us study some more integral formula. X power n dx is equal to x power n plus 1 divided by n plus 1, okay, plus c. So x power n, when it is integrated, what is the formula to be adopted? X power n plus 1 divided by n plus 1. Similarly, for 1 by x, so it is the log of modulus of x, so that you have to remember. So log of modulus of x plus c, and this log is nothing but natural log. So natural log means that is log to the base e, and usually they represent by ln, okay, and some authors they simply mention log, but please understand, on integration it represents natural log only, okay. At the same time, you have to put the modulus, okay. Modulus means it takes only absolute values, okay, plus c. So this is the formula. And next formula, so this is one formula, another formula. Then integration of sin x dx, that gives you cos x. But what about differentiation? Sin x gives plus cos x, and cos x on differentiation gives minus sin x. Here it gives plus sin x, just opposite to differentiation, okay. And secant squared gives a tan x, then cosecant squared gives a minus cot x, then secant squared tan x gives a secant x. Cosecant x cot x is equal to, that is cosecant minus cosecant x. So for all these things, you have to add the integral constant. So these are the important formula. You can take a copy of this later. Then now let us find out this one. You have here integral between the limits of 2 and 3 of 2x squared dx. And if it is having the limits like this, then it's called definite integral. So the integral between the limits of 2 and 3, and 2 can be brought outside the integral. So 2 into x squared dx. So x squared dx means what is the formula? You have to adopt x power n plus 1 divided by n plus 1 plus c. So 2 into x power 2 plus 1 divided by 2 plus 1, and between the interval, what are the limits? 3 and 2. So you had to substitute, this is x cube by 3, and instead of x you can put 3 value, and instead of so 3 value and minus, then put 2 value. So this becomes x cube, and this 2 plus 1 3 can be taken outside the bracket, so 2 by 3. Now we have left over with the that is 3 cube minus 2 cube, because we have substituted, okay, in place of x with the final and initial value. Then 3 3s are 9, 9 3s are 27. So 27 minus 8, that becomes 19 into 2, 38 by 3 is the answer. Okay, right. Next one.